Okay guys, I've done a little digging to this issue with the transplant, and the solution is not as simple as we thought it would be. So just a little recap. This is the bearing puller and assembler, and what they found is that the reaction base plate had deformed or bent by about 1.2 mil on absolute distance, so about 0.6 mil either side. So to solve this, obviously some of the solutions is make it thicker, change it to tool steel, add a back plate. And from what I've seen, once digging into it, to emulate the condition, technically it's not enough. So I will explain. Going into the part here, this is the standard part, and in the initial condition, what I mean is we know it failed by 1.2 mil on either side. How much force would it be required to emulate that? So that equates to a total of basically 32 tons, or probably closer to 34 tons here. And if we look here, you can see that this creates a deformation or a max displacement of 1.2 mil on this corner. That means if this was sitting on the bench here, this is exaggerated by 25 factor, then this lip here would have extended by 1.2 mil from the table. So in actuality it could be half that, but we'll work with this as a safety margin, because naturally the forces and the friction could be different, so it could get worse over time. So then the logical conclusion is, what happens, this is 32 mil thick, what happens if we go for A2 tool steel, which is what this is? So one thing to note with the previous configuration, as bright mild steel at 32 mil, this is experiencing about 1.4 gigapascals of stress, mainly localized in this area. That's mainly where the stress is, and naturally where the hydraulic press is hitting, which I've assumed to be 100 mil in this small area. You can see a lot of the highest stress is actually on the lip of that hydraulic ram, and also at the back area here. Once we apply A2 tool steel, we can see that the stress increases marginally. Why is that? The reason that the stress increases is because tool steel is a harder or more rigid material, i.e. it's less ductile than mild steel, which gives it strength but at the same time makes it more brittle, meaning that the harder the material, the more likely that it will fracture completely instead of bend, as we've seen with the bright mild steel. The displacement is less, so we can see here that with tool steel, nothing changed other than the material. We're getting about 1.16 displacement, whereas it was 1.2 something before. So it's worth noting that the displacement is improved but not as much as we thought. But we've seen that tool steel improves it, but not enough. Then the key point, what we haven't discovered before, is actually the distribution of the load from the hydraulic press itself. And I thought, what if we use, let's say, this back plate here between the hydraulic press as we're trying to extract the bearing. This has a diameter of 180 mil, but let's say we use a similar material, a spacer of sorts that's 180 mil. What would that do to our result? So what that means is that the force distribution is greater. So where the hydraulic press was applying a force here and creating more stresses and a bigger moment, what happens if you have a bigger disc that reduces that sort of deflection? Would that help? And the answer is it does, which we'll see now. So at 180 mil spacer between the hydraulic press and the back plate here, we can see immediately that the stress has already gone down to 294 megapascals, which is less than the yield strength of tool steel, which is about 350. So this is already good result without changing material. Displacement is now at 0.25 mil, which is negligible, and because the stress does not exceed the yield strength, this would spring back into its original condition. Now, to be on the safe side, obviously the next question is what happens if we make it thicker. Hence I've got this little option here. So this is 40 mil thick with the same 180 mil diameter disc to distribute the stress. And what does that look like? So with 40 mil plate, the stress actually goes up marginally, but the displacement goes down again a little bit more. Before it was 0.25, but now it's 0.16. And I suppose I should explain about stresses a little bit more. This is showing the maximum stresses along an area. Just because you add more material, because some of the suggestion is, for example, what happens if we add material to the side here or to the top here, and I've tested those as well, but basically it doesn't help, because as you can see the green line here, this is where the stress is. When you're holding that bit fixed and you're applying a force in the position of the nuts here, then naturally this bit is experiencing the stress of those forces. Less so at the top here. So adding more material here doesn't reduce the stress it's experiencing here. Adding more material here, because you can see it's cold and blue there, doesn't reduce the stress here. 40 mil plate thickness improves. So between 32 mil and 40 mil, it's a big help. So this is the 180 mil on this side, the stress and displacement. This is 32 mil this side and 40 mil this side, and we can see that at 40 mil you actually increase the maximum stress in that specific point, purely because you've added material and there's, let's say, more to go around. I'm not sure how that translates, but ultimately you've reduced the displacement by another 0.08, 0.09 even, between these two. So 40 mil does help, about the same as the addition of converting this to tool steel. So we know that 40 mil helps. What else could we do that would improve this? Naturally, it's the back plate, which we talked about as well. So now that you add a back plate here, the idea is that you distribute that sort of stressed area along this little bar, and let's see what that looks like. So the stress is reduced significantly. I believe this is, I'm not sure, but I think this back plate is, I want to say 40 mil. Yeah, it's 40 mil thick with a back plate, and the displacement I think was down again a little bit more. This was 0.16 something, now it's 0.15 something. But again, it's good that the stress, or the maximum possible stress experience, is less than the maximum yield of a tool steel. And just to go the extra mile, this is the 50 mil variation. If we made it mega thick like so, you can see that the stress is now at the 200 megapascal region, and the deflection now goes to 0.009, so nearly 0.1 mil. So a big improvement still. And finally, I had to play about with like the maximum ultimate, probably overkill design. So if we notice here, there's some space here that helps the distribution of the stress, because this is acting as a puller, and you're basically applying a bending moment only on the left and right lip of this plate. You're deliberately trying to bend it. As another configuration, what we could do is this assembly where you add 2 more studs into the free space there, and you make this plate more or less mirror that kind of puller of the bearing. And obviously I can add the little back plate here as well, which I did mess about doing. So this is the final form, let's call it. And we can see that the stress is now at 1.4, because it's distributing each of those green areas along the back plate, along each of the 6 points where the studs are, or the nuts are hitting, and obviously against a wider area. So that is very good. I dare say that's one of the best results we could possibly achieve. And this isn't even 50 mil. This is, I think, 45 mil. So it's not too heavy, too cumbersome. And the displacement of this one is 0.07 mil, which is better still than what was the 50 mil plate without this extra bit. I would say 40 mil with a back plate is potentially the best result, and that is still within the yield and very, very little displacement, 0.15. But naturally we have more options to improve this further. Go to 50 mil if we'd like, with the back plate like 60-70% within the yield, and 0.1 mil displacement, so an even bigger improvement. So them's the options, and hopefully that, well, more than likely will remove the issue that they're facing, at least according to the initial conditions applied. These are just some snapshots of comparisons that I've done. But yeah, that if we have the appetite, this is the ultimate design with a little back plate there. If you want to keep it simple, a 40 mil thick plus a back plate and a spacer here would complete the job.